My name is Ben. I worked on the rendering pipeline as well as the image generation and some of the front end.
Hi, I'm Omar, and I collected data, cleaned it, and prepared it for our XGBoost models.
Hi, my name is Rehan. I worked on the image generation using the DALL-E 3 API for humanized prompts.
Hi, I'm Wally. I worked on the back end where the models interact with the data, and I also worked on the front end where the user interacts with our models and our framework. 2, 1.
Hi, my name is Ahmed. I worked on the machine learning inference layer where I trained models on the Toronto Open City data to give an appropriate analysis for the findings of the user. Toronto approves 2,000 plus development applications a year, worth over $4 billion. There's no public tool to understand what any of them actually mean. The data exists: traffic, zoning, trees, and transit, but it's scattered across disconnected city portals. We ended up building an application called UrbanForge, which is an AI-powered platform that helps people see how new buildings affect Toronto before they're built. Users can place a building anywhere on a live map and instantly get a realistic 3D render, along with predictions for traffic, energy use, housing, infrastructure, and economic impact. The system uses Toronto Open Data, custom XGBoost models, and a local NVIDIA NeMoTron chatbot to turn complex urban data into clear, useful insights for residents, planners, and developers.
So let's go into a high-level overview of how this works. Let's say you query the backend with a new spec, something like Seattle Space Needle, right? What it does is it creates a hyper-realistic image using DALL-E and then prompts the user, again, if it looks good. This gets sent to the front end. And then if the user agrees, it sends that image to our GX10, which is running Trellis 2, in order to 3D render it with a custom sort of GLB. And then after around 10 to 15 minutes, it returns it. And then we pass in a couple parameters into our NeMoTron model. Well, actually, we pass it into the various different models that it's connected to that analyze things like electricity impact or housing impact, or maybe the impact that a building of this scale would have on traffic, the jobs it would create, the environmental impact. Those are the main ones, but the implications that it has take from a variety of different open source data across the city. And then from here, we return a traffic score or an impact score, which is from 0 to 10. And yeah, this is how users can get a sort of picture of what the building will A, look like, and B, due to their area, just by prompting AI. So let's say this land outside of Etobicoke is being constructed on. Something that maybe like fits the area around it, something like a brutalist concrete skyscraper. Let's see if we can generate it using this area and then see maybe the impact it has. So let's actually redraw it. It looks a bit too big. Maybe something like this would be more appropriate. And then it's looking a bit out of line with the building. So let's go something like this. Yeah, brutalist concrete skyscraper. Let's generate this image and see what it creates. Okay, yeah, this is everything I ever dreamed it would be. It looks just like the areas around it. So let's go ahead and generate a 3D model. And this usually does take 10 to 15 minutes because of how heavy Trellis 2 is. But I'll check in when it's done. And there we have it. Our entire building generated from one prompt. From here, you can either rotate it and see how it looks like from different sides. Or, and the big thing here is you can use NeMoTron in order to analyze the impact. This is really cool, so let me show you what this looks like. It's done loading, and you can see the impact that it would have on the area, a brief impact summary. So something like 65 impact score, which is just a aggregation of all of these. But let's look specifically, and you can see the environmental impact is pretty low for the reasons they mentioned here. But things like the traffic load, because of the area it's in and the volume and the area it's taking up, you can see that would be pretty high. I mean, it is a single lane highway and a residential area that leads to a 24-story tall concrete structure. So that's to be expected. And then you can see all the other ones that we decided to show for this demo. But the beauty of this is through NeMoTron, you can actually train your own models and tack them on as well. So if you wanted to see something like pollution or maybe something like resource expense, you could train models as well on open source data as long as the quality of data is good enough and attach them here as well. You can also ask follow-up questions like, what is the traffic impact? And then it goes more in depth into why it chose that rating or why it decided that it's going to be a considerable strain. And you can read the reasoning here. But yeah, this is also something run through NeMoTron and something that our product supports.
Anyone can already look up a building permit online. Here's the difference. We turned 6 disconnected city datasets, 3 machine learning models, and a 4 billion parameter reasoning model into a 2-second answer that a resident, a planner, or an investor can actually act on. We pushed the DGX Spark to run real-time spatial reasoning, ML inference, and LLM generation simultaneously on live city data in a product that did not exist 36 years ago. Cities are being reshaped every year by decisions that most people never see coming. UrbanForge changes that. Every city, starting here.
Tough.